The physical properties of alkanes, they're fairly straightforward. We're going to look at melting points and boiling points here, and some basic reactions. So the major intermolecular force of alkanes is London dispersion forces, right? They're basically nonpolar and they're hydrophobic. That means that they don't like water, right? Now when we talk about boiling point and melting point, we have to consider branching. So unbranched alkanes is what I want to look at first with you guys. So as far as boiling point is concerned, if we have an increase in the number of carbons, that just means that you're bigger, right? That means you have an increase in molar mass. And if you recall, London dispersion forces are related to that. The more electrons a molecule has, the more London dispersion forces you're going to have, essentially. And that's going to increase boiling points. So if you look down here below, here we have 5 carbons, right? A boiling point of 36. We go up to 2, 4, 6, 8, octane. That has a boiling point almost 100 degrees higher than that, right? 90 degrees higher. So melting point follows that same trend as far as our boiling point. Increase in the number of carbons increases our LDFs, and it increases the melting points. They pack better, right? Because they can sit on top of each other a little bit easier, right? And also they have stronger LDFs, right? So again, going from negative 130 up to negative 57, right? That's a larger number, even though they're both negative. Now, what about branching? Well, branching complicates things just a little bit. So as far as our boiling point is concerned, if we have an increase in branching, we have a decrease in exposed surface area. Right, which decreases our London dispersion forces and decreases our boiling point. So as we look down below here, we have isomers of C6. So 60, right, a little bit more branching, 58, more intense branching at 1 carbon pulls you down to 50. Well, what about melting point? Well, becoming more symmetrical or spherical, right, increases our ability to pack into a crystalline structure, which increases the melting point. Right, so note here that the simple branching from linear alkanes does lower the packing ability and decrease the melting point. However, more extensive branching causes an increase in packing ability. Right, so we kind of see extremes here with this. So we go from negative 154 down to negative 135 and down to negative 98. Now, looking at the reactions of alkanes, we're going to see some reactions in this next chapter, but for now, you can basically do 2 things with them. You can burn them, that's combustion, or you can do something called cracking, which is taking a longer carbon chain and using here hydrogen and heat. Sometimes in OChem we use this little triangle to indicate heat, and a catalyst, and we get shorter little fragments of that longer alkane.